I will discuss to understand L2 routing. Today we will use one tool called Mininet and another is a Python script. And as you might know that as you might know, or else you can say that many of you in your bachelor studies have studied about OSI model and TCP by IP stack. So like what's the difference between them? That in OSI model we have 7 layers. In TCP by IP we have 5 layers. So what is L2 routing, right? L2 routing means L2 routing is done on the data link layer of TCP by IP stack, right? Yes, TCP by IP stack. And for doing L2 routing we use MAC address instead of IP address. So then what is MAC address then? MAC address nothing but just it's a address which were given by device manufacturers, and every device which existed will have a MAC address. And so the device manufacturers usually what they do, they will burn the MAC address on the hardware itself. So you can say any device which is connected to network will have a MAC address. So how do you know what is MAC address of your machine? And you can know by a simple command as ifconfig, as it here you can see ifconfig. And so ifconfig, where do you type this command? You can type this command in your terminal, or a MAC address will look like something like this, right? Can you see it? Yeah. And so L2 routing will be done purely on MAC addresses, not on the IP addresses. And then to understand this L2 routing, we will use a tool called Mininet, right? A tool called Mininet. So you will ask me, what is Mininet then, right? A Mininet is a simple tool through which you can create a virtual network. It help you creating a virtual network through switches, links, nodes. It will create a virtual network, and we can also say that Mininet is a emulator. That means you can virtually create a real network, and moreover through Mininet we can do experiments. And another reason why we use Mininet is because it is inexpensive, and moreover it has a ton of Python APIs for creating a real network. So then how do you install it then, right? How do you install it? To install Mininet on your device, you need two things. First, Mininet disk image and VirtualBox. So VirtualBox, have you ever used VirtualBox? Have you ever used Linux? Let me show you how VirtualBox look like. So this is my VirtualBox. I'm having a Ubuntu Linux machine and similarly a Mininet machine. So what is VirtualBox? A VirtualBox, like it is it's like a window. Like I'm having a Windows 7 operating system, but I'm using Ubuntu Linux with it. So we can say that like we can use two operating system inside one operating system. What do I mean by that? It's just like it's a simple I'm having a Windows operating system, so with Windows operating system I'm using Ubuntu Linux with it. So then how do you install Mininet machine then? Yeah, you can install your Mininet machine on your Mininet machine on your device. First you need a Mininet disk image, and where you can get it, Mininet disk image, you can get it from here. And this were my these were my blog articles, and you can see it in your you can also see it. I will keep these links in the video description so that you can also see it. So you just go down from here and download any link from whichever operating system you have. If you have 32-bit for machine, you can download from here, and for 62-bit, after downloading the link, you can download the VirtualBox, and you can download from here. For Windows you can download from here. For Windows you can download from for Linux. So you can download VirtualBox, and after you install it, when you install it, just click on the files and then import application. When you do import application, select the file, the Mininet disk image file, which we have just now downloaded, right? Then press next, then import. So as you have downloaded the VirtualBox and Mininet disk image, then you imported the Mininet disk image on the VirtualBox. Then after that, let's start it. Let's just see how Mininets look like. Okay, I'm starting it. Mininet virtual machine. So like if you also want to start it, just like select the machine and press start, and it will start the machine. Yeah, it will take little time, so wait for it. So the machine is getting started. So our machine is ready, as you can see. So what's login? Then what should you type? You type just Mininet. Oh, so what's the login address then? Nothing, just type Mininet. Then password will be also same, Mininet. Press enter. So you log in into your machine. So what can we do in Mininet then? So we can check whether our Mininet can receive internet, and we can check it whether our machine is getting internet or not by a simple command: ping google.com. So that means we are able to connect to the internet. So we can see that our device is able to connect to the internet. So we will exit. How do you exit? Control, if you press Control C, you will exit out of it. And so next what we will do, we will check our MAC address or our IP address, right? So look, I've typed the command ifconfig. So this is the default. When you see something like that 10.0.2.150, it's a default address. And what else can you do? And to exit the machine, you just have to type exit, and you can exit out of it. Again I will log into the machine. Mininet. Okay. Okay, yeah, our machine. And one more thing you can know here, that the commands which you use, it is similar to Linux. Like you can list all the folders here, and you can get into the folder, any folder like git underscore, and list here. Can you see it? Yeah, it's similar, like same as Linux command. Most of the commands which you use on Linux, you can also use on Mininet. And one more thing, it's better if you use SSH client to connect your Mininet machine with your Windows operating system. How can you do it? You can do it by using MobileXtem. Download the MobileXtem from here, and the articles which I am showing on the PC, you can also see it. I will mention all the links, blog links, in the video description, so that you can also see it. And download the free edition and install it. After you install it, not mininet machine but VirtualBox. Go to and select this and go to settings and go to networks and change the adapter attached to bridge adapter and press OK. Now check if config. Now we are getting 192.168.1.10 1.10. It is different from the previous which we are getting 10 dot something like that. Why? Because we have changed our network configuration to bridge. So you should also have to change your network setting, because we will like to use SSH client to connect this machine to the to MobileXtem. And how to use your mininet machine in MobileXtem? Just start your machine. It will take little time to start. So what I will do, I will note down my address. What is IP address of my machine is 192.168.1.10. So this is my window machine. So what we will do here, we will check whether we can connect our MobileXtem to the mininet. How we can do that? You can do it by a command. Just ping 192.168.1.10. Yes, this is able to connect to the. Can you say it? Yeah. Yes, I am able to send packet sent 4, received 4, so loss 0, so there is no loss. That means we can connect to our mininet. Then how do you connect your MobileXtem? How do you connect your mininet machine in MobileXtem? You need to type SSH mininet at and your IP address. SSH mininet @ and my IP address 192.168.1.10. So I press enter. So it is asking password. Password is same, mininet. Do you want to say password? So I am into my mininet machine. You can say like this is my mininet, which I connected through MobileXtem. So this is how you connect your Mininet machine through Mobile XTEM, and you can use it in your Windows operating system. And it will be easy when you use your Mininet in your Mobile XTEM. So this is okay. Let's see how to create a new session in Mininet. Not Mininet, but Mobile XTEM. And to create a new instance, to create a new session in Mobile XTEM, you need to click SSH and type your IP address of your Mininet. In my case, I have IP address of my Mininet as 192.168.1.10, and username will be Mininet. Then press OK. And type the password as Mininet. Press enter. No. Yeah. Can you see here? Your Mininet new session is created. Look, our Mininet machine that we have. Okay. Now what we will do? We will see some basic topologies in Mininet. Okay. Suppose this is a network topology. Suppose we have a switch and two hosts H1 and H2, and H1 will have H1 have a IP address 1.1.1/24, and host H2 has IP address as 1.1.12/24. So this network topology we can launch in Mininet by a command, simple command as sudo. See, sudo mn. Can you see it? When I type the command sudo mn, it created two hosts H1 H2 and a switch S1, and adding links. See our topology. We have switch S1 and two hosts H1 and H2, and there is a link, is there between switch S1 to host H1, and link is there from switch S1 to host H2. Look, we have created two hosts H1 H2, one switch, and as we have seen, our topology has a link from H1 to S1 and H2 to S1, and now it says configuring host and starting controller and starting one switch. So this is, I'm just showing you simple topology. Let's see another topology. Okay, so as we have launched our topology, we will check. As we have launched our topology, now check interface of your host machine by a command h1 if config a. h1 if config h1 if config dash a. So h1 if config dash a shows you the interface of your host machine h1. As we have seen in previous topology that we have two host machine, one switch. So for host machine h1, this is the interface, IP address, and so let's see host to interface by the same command. Can you see it? The IP address of h1 will be 10.0.0.1 here. The IP address of h2 will be 10.0.0.0.2. So this is how you can check the IP address of a host machine. Now next what we will see, can we ping h1 to h1 ping h2? Yes, we are able to ping h1 to h2, and it will be continue like this. To exit out of this mode, you need to press Ctrl C to exit out of this mode. What does it mean, h1 ping h2? It means that we have a link from h1 we have a link from host h1 to h2. So can you ping h2 ping h1? Yes, we can also ping h2 to h2 ping h1. Similarly, it is also means that we have a link from h2 to h1 from our previous topology, and to exit this mode you need to press Ctrl C and you exit out of this. See our topology, we have link from h1 to h2 and h2 to h1. So this is how you can check it. And also you can type h2 to and h2 ping your interface IP address. Host machine h2 ping IP address of h1 is 10.0.0.1. Can we ping it? But look, h2 is our host machine, and 10.0.0.1 it's IP address of host machine h1. Yes, we are able to ping host machine h2 with host machine h1. Similarly, you can also ping it like that. Okay, now we can see what we can see is links. Yes, we have two links h1 two links, that is Ethernet 0 and Ethernet 2, which is two host machine. This is a two links, and You can see even more information by command dump, not dump, this p, not b, dump. Yes, you can see, yeah, we have seen even more information. And another command is net. So it will show the connectivity between the between two nodes of the topology. So this were the simple commands that we can use in order to analyze our topology which we have created. Let's see another example. Let's suppose we have 3 switches and 4 host machine, and we can launch this topology by a command sudo mn dash dash topology is equals to tree, comma depth is equals to 2 and fan out is equals to 2. And I have copied the command and I have paste. And to look here, to paste the command you need to right click, just right click it and you will paste the command. So just I will enter. So what happened here? Yeah, it's sorry. What happened here is I haven't exit from the first topology which I have created. Okay, the connection is closed, so once again I will log into it. SSH mininet at my IP address 192.168.1.10. and password is mininet. No. Okay. Now I pasted the topology command. See why we got error last time, because we didn't exited the previous topology. Okay, so can you see with this command sudo mn dash dash topology is equals to tree and depth is equals to 2 and pan out is equals to 2. With this command we have created 4 hosts, h1 h2 h3 and h4, and switches, 3 switches we have added, s1 s2 and s3, and links from s1 to s2 and s1 to s3 and s2 to h1 and s2 to h2. And so here fan out, in the command fan out means that the children that each node will the children that each node will have will be 2. So we have created 2 children from the node s2 and s3. So it's just a simple example to show you like how with this command you can create is network topologies, so that you can launch your network. Similarly, you can also use the same commands which we have previously used. You can also use the commands like h1 ping h2. Yes, you can see we can ping the host machine h1 to host machine h2, and you can exit by control C. Okay, and similarly you can h1 ping h4. Can you see it? Yeah, h1 ping h4. So, and you again press Ctrl C to exit. Yeah, so this is a two topology example I can give, and we are into this network topology, and you can exit from this topology by exit exit command. Look, we have closed the topology which we have just now we have created. So this is how you can exit out of topology. If you doesn't exit out of the topology, if you write some command, again it will show some errors. So first, when you create a topology, then you have to exit out of the topology, then to get into the Mininet terminal. So again we have came back to the Mininet terminal. So this is how you can create network topologies in Mininet. Let's see how this is two simple Mininet topologies I have shown you. Network topologies I have shown you, and we can create even more complex topology network, even more network topologies with Python, right? And how do we compile a Python code? How do we compile a Python script in Mininet? First, what we will do here, let's check whether we have a Python in our Mininet. Type Python, and okay, Python, sorry, the spelling mistake. Okay, we have a Python as Python version 3.8.5. Okay, we are in. So when we have typed the Python command, it shows that our Mininet machine have a Python version 3.8.5. so you can exit from here by typing quit and be back. Once again we are back into our Mininet machine. So what we will do here, we will create a folder called Mininet programs. Okay, so we have created a folder or directory, you can say. Let's see where. Yeah, can you see just now we have created Mininet programs. So now what we will do, we will get into that directory mini net programs and press enter. We have get into that folder and see it is we will create a Python file. And to create a Python file, you need, okay, we can create a Python file by a command cat greater than demo.py. This command will create a Python file. Okay, now type the script: print double quote, this is just a simple program, close double quote, enter, press Ctrl and D to save and exit the program. So this is just a simple Python script. It is a Python script, so we don't need to write a main function and studio.h. And okay, we have created our Python file and written our script. Now we have to do is compile our Python script. And you can compile your Python script by a simple command: sudo python and your file name demo.py, enter. Okay, we have created our file demo.py and we have compiled our program. Compile our script, and so this is our output. This is just a simple program. This is what we have written in our script, right? Okay, so this is how you can compile your Python programs on Mininet. Till now we have seen like how to install a Mininet on your PC, and then what we have seen like how to create a topology in Mininet with the simple commands. Then and also we have seen why we are using Mininet. Okay, then we are using Python. Why we are using Python? We are using Python because with the help of Python we can create more custom topologies. Okay, now let's get back to our L2 concept. Okay, so as we have discussed, L2 routing is done on the data link layer of the TCP by IP stack. So how many layers are there in TCP by IP stack? There are 5 layers: physical layer, data link layer, network layer, transport layer, application layer. So L2 routing, we are doing L2 routing on data link layer. Okay, and as you can see, every layer on the TCP by IP stack, there is a I have mentioned some famous protocols. For application layer, HTTP is a protocol. For transport layer, UDP and TCP are the protocols. Okay, network layer, IPv4 and IPv6 are the protocols, and for data link layer, Ethernet is a protocol. So then you will ask me, what is protocol then? What is protocol? Protocol is nothing, just it just a set of rules, we can say it. Okay, now let's see as you can see, every in the TCP by IP stack we have 5 layer, and every layer has a different protocols, right? So for data link layer, Ethernet is a protocol, and the Ethernet and the Ethernet protocol header will contain a extra information, right? Some kind of extra information in it. It's not just in data link layer that information is present. In every layer protocol, we have some kind of extra information. Why we need this extra information? To know, suppose I will explain why we need it. Suppose for Ethernet header protocol, we have a type. We have a extra field called type. So why we need type? So like, for example, if the value of the type is 080, it means that the protocol on which the network layer is running is IPv4 protocol. Similarly, if the look, this I'm talking about this type field. If the value of this type is 041, then the protocol which is operating on the network layer is IPv6 protocol. So that it means like the current protocol will let you know what protocol is operating on the next layer of it. Okay. Similarly, the network layer is also there is also a field is available called protocol. Okay, you can see protocol, and if the value of that protocol is 6, then it means that the transport layer protocol is TCP protocol. Similarly, if the value is 17, then the protocol that is running on the transport layer is the protocol that is running on the transport layer is UDP. Okay, and okay, we have discussed Ethernet and network layer. And for transport layer we have a port number. Like, this is extra bit of information. The thing for transport layer we have a port number, and in application layer, look, in application layer we have protocol as a HTTP, and on application layer all the applications will be run by it. For example, software applications like your WhatsApp and Facebook, something like that. So these were the applications that will be run on application layer. So the port number will determine, like, the port number will determine what application that it has to deliver the packet to it, right? Okay, For example, suppose consider in app 1 at the application layer is there. Okay, and suppose if the application is receiving on port number 18, then if the packet arrive on the machine with port number 80, at this instant the operating system will deliver the packet to the app 1. Did you get my point, what I'm trying to say? Suppose there is a app called app1 is present on the application layer. Okay, and that app1 is receiving packet with port number 80, suppose, and if the port number is 80 on the UDP TCP protocol is 80. Okay, then it will be delivered to the app1. Why? Because the app1 is receiving on the port 80 only. The packet will deliver to the application 1, the application 1, right? Okay, let me explain to you once again. We have a field called port number on the transport layer. Okay, and we have a app, suppose we have an app called app1, and it is receiving packet on port 80 only. So if UDP protocol receive a packet with port number 80, then the operating system will know that the packet has to be delivered to the app1, right? So this is the logic behind it. So I think you have got how a packet get framed in TCP by IP stack. Okay, I think it's clear now, and we are more concerned. Okay, this is how a packet get framed in TCP by IP stack. So we are in this video we are discussing about L2 layer. That means the L2 layer, L2 routing. We are talking about L2 routing, and L2 routing will be done on data link layer. So we will discuss about Ethernet protocol, right? For Ethernet protocol, we have 6 fields. For like it is for Ethernet protocol, this Ethernet frame, a frame will be there, and which will have 6 field, and the first field will have 8 bytes, and the destination MAC and the second field will be destination address, which is 6 byte, and the source address will be 6 byte, and next will be type field, which will be 2 byte, and the info will be minimum 45 and maximum 1500, and the last field will be for checksum, and which will be 4 byte. So this is the Ethernet protocol header format. So can you see here we have 6 field in the Ethernet header format. We are we are specifically interested in Ethernet protocol. Why? Because we are talking about L2 routing, and L2 routing will be done on data link layer, and data link layer of the TCP by IP stack, and TCP by IP stack will have Ethernet as a protocol. So what could be the maximum size of an Ethernet frame? We can say 8 plus 6 plus 6 plus 2, 46 plus 4 is equals to how much? 72. How I am saying 8 plus, this is, look here, 8, 6 plus 6 plus 2 plus 46 plus 4 equals to how much? 72 bytes. So this is the minimum size of an Ethernet frame, and for maximum, instead of 46, you should use 1500, and it will become 1526 byte. So minimum size will be 72 bytes, and maximum bytes will be maximum size for an Ethernet frame will be 1526 bytes. Okay, and here okay, this is we have discussed about Ethernet frame, and the minimum size for the Ethernet frame will be 72 byte, and for maximum size of an Ethernet frame will be 1526. Okay, then. Okay, now we will discuss about how actually L2 routing is done. Okay, for that I am using a simple topology. In this topology we are having 3 machines: machine A, machine B, and machine C, and a L3 router, and this topology is connected to a internet. And here for machine A, MA is the MAC machine. For machine A, MA is the MAC address. For machine B, MB is the MAC address, and for machine C, MC is the MAC address. Similarly, for machine A, 12.1.1.1.2/24 is the IP address, and for router L3 router, this is the IP address. Similarly, these are the IP address. So suppose machine B wants to send packet to the machine A. How it will send the package to machine A? To send a packet from machine B to A, it will take 3 steps. First, what B will do? First, B will prepare the packet Ethernet header with source MAC address as a MB and destination MAC address as a MA, and type will be 08004. And instead of 08004, if you want another protocol which is IPv6, in that case you have to mention 00, what we have seen previously, 0041. If the type is 0041, then instead of IPv4 protocol, it will use IPv6. Okay, so this is the first step. In second step, what in second step the machine will transmit the packet on a wire. So when it transmit the packet on a wire, then the packet will be received by the uh, all the remaining machines in the topology. What are the remaining machines in this topology? A, C and L3 router. When B sends a packet to the A, it is civil. Then when it sends the packet to the machine A, then all the machines which are present in the topology will also receive the packet, right? So in the so how the machine A will know that the machine B has sent a packet to the machine B has sent the packet for the machine A only, not for the machine C or router. It will know. How it will know? The machine, all the machine presents in this topology will check whether its destination MAC address equals to the receiving interface. In step 2, machine B will transmit the packet on a wire. So it means when it transmit the packet on a wire, then all the machines present in the topology will be receive the packet. As we have seen in our above topology, we have 3 machines, A, B, C, 3 machines and 1 router, and we consider L3 router is present in the same topology. So the packet B with the packet sent by the B will receive by all the remaining devices on the topology. So how A will know whether the packet sent by B it is destined for it only? It will know through if the destination MAC address is equal to the MAC of receiving interface, then if it is equal to the MAC of receiving interface, then A will know. Then A will accept it. If it is equal, then only it will accept. Otherwise, if it is not equal, it will. If it is not equal, then it will reject. As you can see, in our case, only machine A only accept the packet, and remaining devices like C and L3 router rejected. Why? Because the destination MAC address of the packet is not equal to the MAC address of the C and L3 router. So this is how L3 router is done. Through 3 steps, what we have done L2 routing. How we did L2 routing? We have sent the packet from machine B to A. So this is how L2 routing is done, and you have noticed that that it is done purely on MAC address, not on the IP address. And you will have a doubt that how a machine B will know the MAC address of machine A. look, our goal is to send a packet from machine B to A. Then how B will know the MAC address of machine A? It will know the MAC address of A through ARP protocol. Oh, initially what we have done, or initially what the machine B has done, machine B has send the packet on the wire, physical wire, and when it send the packet on a physical wire, the packet will be received by the machine C L3 router. So how a machine A know that it is destined for it? When its MAC address is equal to the MAC of receiving interface, then only it will accept it, otherwise it will reject it. So this is how L2 routing is done, and B will know the MAC address of A through ARP protocol. So ARP protocol is nothing but the address resolution protocol. So what about the machine C and also L3 router? They are unnecessarily getting disturbed, for that we call at a thrashing. Look, what do I mean by that? Thrashing. Machine B send a packet for the machine A, right? And when it's send a packet on the wire, the packet will be received by the all the devices on the topology, and all the devices present in the topology. So look, the goal of B is to send a packet to the A, but the packet is also being received by the device C and L3 router. So it's unnecessarily they are getting disturbed. How it will be solved? How the problem of like other devices getting solved? That problem will be solved with the help of L2 switch. So L2 switch will solve the problem of thrashing. Okay. The final part of this video, we will create a custom topology by using a Python program. Python program means Python program. And when I'm saying Python program, it's not about writing algorithms or something like traversing array or inserting an element in an array or deleting in an array. So, no, we are not going to use any algorithm or something, just basic simple commands through which we will create the topology. Okay, let us see how we can do that. Okay, this is our topology, and this topology we will implement in a minute. So what this topology have? A host H1 and host H2. Host H1 has a loopback IP address 122.1.1.1 by 32, and 122.1.2 by 32 has a loopback address, and a L2 switch and a VLAN 10. An L2 switch have two interfaces, S5 Ethernet 0 and S5 Ethernet 1. And so what is VLAN? VLAN is nothing but a virtual LAN. And if you have if you know that VLAN will perform better than LAN. And the drawback of LAN is that, but the LANs will have two drawbacks. First drawback is immobility, and the second drawback of LAN is it will have security issues. Because of that, we are using VLAN. And you know, for L2 switch help us in the solving the problem of thrashing, as we have discussed in previously. So this is the topology we will implement in Python. And both the host h1 and h2 fall in a same subnet. So what is subnet? Subnet means subnet exists when two device, suppose VM1 is a device, VM2 is a device, have a common when two devices have a common link between them, and both the when we apply a so for a subnet to exist, it need to satisfy two conditions. First condition is interfaces of the two devices should interconnected via a common link, and the interfaces should be assigned an IP address such that both fall in a same network ID. What does that mean? I will explain. See, we have two devices, VM1 and VM2. VM1 has a IP address of 192.168.1.1/24, and VM2 also has an IP address. So then here the subnet value is 19.168.1.10, and this network ID will be same. This network ID will be same for the both the machines. For a subnet to exist, two devices should have a common link between them, and the second condition is that if we apply a mask value of 24 on an IP address, then you should get the network ID value such as 192.168.1.0. and again, if you apply to mask value of 24 on IP address, you will get the same network ID. So this is the concept of subnet. Okay, H1 has to fall in same subnet. And the VLAN is used in access mode. Okay, let's just see our about topology how we will. And okay, I don't want to type all the program. I will just copy and paste it here. So how I can do that? I can do it by I will go into my Mininet programs. Our previous file is also existed there, so I will create new file, cat greater than demo 1.py. Hit enter and right click and press OK. Okay, and See, uh, one thing you should note here, that to paste code in the mininet, you have to just click the right click, then it will automatically paste. You don't need to type a control V. Okay, so let me explain the code here. Here we are using three APIs. I will explain in the website because look, this is API. We are importing Mininet, network emulator, and command line interface to talk to nodes, and another API is links. And from this were the Python APIs. This were which helps you create the above topology, and where you can get this Python APIs, you can get from here. See, this is Mininet Python APIs. This is the same API we are using. Okay, and see, now what we are doing here, it is a main function, Python main function. Where the execution of program start from here. Now we are creating instance of Mininet with the variable network, and now we are adding a host h1 network dot add host h1, and again we are adding host to see our topology. We have two hosts, h1 h2, so we are adding two hosts. Then we are adding a switch. Network is okay, we are adding. So look, first we added two hosts, h1 and h2, then again we added a switch, then we will add links from h1 to h5, from h2 to h5. We are adding links from h1 to s5. S5 means here switch. So what we did till now, we have added host h1, host h2, and a switch. Then we added a link. Again we added another link. Now network dot build to build the topology. Okay, then in the next, what we are doing, we are removing the default IP address from the host h1 and host h2. Why? Because in h2 routing, there is no need to use IP address. H2 routing only done on the purely basis on the MAC address. No, there is no need for IP address. Okay, we are removing the IP address, default IP address from the host machine h1 and h2. Similarly, we also removing default IP address from the switch, default IP address from the switch interfaces. Okay, you can see we have two interfaces for switch, one first interface and second interface. Now we can create a VLAN on switch, and bring up the VLAN interface on L2 switch. Okay, and to and when we are using VLAN on L2 in access mode, for that we are using this command, and this is the first interface of the switch, and this is the second interface of the switch, which both are connected to a VLAN in access mode. So that's why we are using this both commands to connect to VLAN in access mode. Again, for the we are assigning a IP address to our host 10.0.10.1. Look, this is the we are assigning IP address. What we have done. Look here, this is just a simple commands. You don't need here we are not writing any logic here. It's just a simple, like how Linux commands are there, like that simple Python like something commands like that. You are not writing any logic here. It's just a simple commands. Okay, there is no big deal. Just you need to just remember it, and you can write it. Right? Here we are not writing any logic here. That's simple. First, what we have done, added two host machine, then we added a switch, then we created two links. Created two links. Then what we have done, we have removed the default IP address of the host H1 and H2, and again we have removed the default IP address of the remove the default IP address from the switch interfaces, first interface and second interface. Then we added a VLAN. Then we add the VLAN in access mode. At last we are assigning IP address to our host machine H1 and H2. At last we are adding assigning IP address to our host machine H1 and H2. This is for starting a mininet CLI prom, and we are stopping our emulator. Okay, this is how we wrote the Python script. The same screen which I have explained you, I have just copied and pasted here. What we have to do now, press enter, press Ctrl D to save and exit the program. How we can compile this program, as I have shown you before, that you should write sudo python, and the file name is demo1.py. okay, as we have built our custom topology with Python script, let's test how we have built our custom topology. Okay, we'll check how we have actually built it, and we will see through the commands which we have discussed, like simple commands like nodes. For nodes, like the topology we have built, that have two hosts H1, H2, and a switch. Let's see some more commands. to dump command for to see even more information related to host h1, h2 and h5. And net command to see a relation between connectivity between host h1 and h2 and other nodes. And command h1 if config. This command is for to check the interface of the host machine h1. Sorry, I give a space between the if config. If so this is the interface of the host machine h1, and the IP address is 10.0.0.1. Similarly, you can also check interface of the host machine h2, like h2 if config. Let's ping h1 with h2. As you can see, we can ping h1 to h2. What does that mean? It means we have a link between h1 to h2. When the ping command able to run, that means we have a link between h1 to h2. So you can exit out of this ping command by Control C. Okay, let's see, do we have any link between h2 and h1? Yes, it's also running, so it means we have a link between h2 host machine h2 and h1. So exit out of it by Control C. Let's see root table of host machine h1. So this is the root table of h1. And let's see ARP table of. So this is the ARP table for host machine h1. So okay, we have seen how to build a custom tuple. We have seen in this video what we have seen: how to install a mininet, how to compile a Python program in it, how to run a simple topologies in a mininet, and how to create a custom topology in mininet with the help of Python program. So okay then, bye for now. Okay, bye.